Assalamualaikum and good evening. Today we will cover chapter 5, estimation of survival models for complete data. So as an introduction, I will like to introduce you a complete data versus incomplete data. However, for this chapter, we only cover complete data. So complete data, each study units are not permitted to withdraw from the study without failing or dying. Generally found only in clinical studies where the observation period is fairly short, so the period must be short. Thus, the variable of interest is the time of survival since some initial event denoted as ST. The estimate of ST will be denoted as S hat, ST with the hat. So, the time of observation must be short, and then the observation of the survival of the subjects from some since some initial events, so it starts from 0, so for C points, and then short period of time of observation, and then the estimator of ST denoted as ST with the hat. Okay. Incomplete data, on the other hand, refers to situation where study units can withdraw or lost from observation before death. Thus, information regarding the survival pattern of the entities under study is lost. Okay. We will go to the example. How many students sleep in the class for the first 10 minutes? Okay, for example, we have 50 students in the class. All students must enter the class at the same time. We call it as initial point at t equal to 0. So all these 50 students must get into the class at the same time at t equal to 0, and then until t equal to 10. So the t is in terms of minutes. So these students have observed every minutes until the end of observation. So t equal to 0, start of observation, t equal to 10 is end of observation. And all students are not allowed to leave the class. So until the end, all the students must be in the class. So at the end of the observation, the total of the student in the class must be 50 as well. So from time to time, we will check how many students go to sleep, for example, but they're still in the class. They just leave the observation because they are sleeping, not because of other event. So our event of interest, sleeping in the class or not. So other event, let's say they want to go to the toilet or other than sleep, are not allowed. They still have to be in the class. Okay, so incomplete data, we take the same example. Within the 10 minutes, t until 10. So maybe at t equal to 1, 2 students go to toilet and leave the class. At t equal to 8, for example, 4 students went back to hostel because the class is too boring. So they leave the class not just because of they are sleeping, but because something else. So total of students here 50, and at the end of the observation it will decrease, not just because of the students are sleeping, but also the other event. So we call it as incomplete data. Still remember in chapter 1 we cover this cross-sectional study and longitudinal study. We will have observation thoroughly, and the observation period is smaller than cross-sectional study. So the initial group, or the group at t equal to 0 forms, we call it as a cohort group. And cohort group can be gathered in two ways. So first method, all study units are gathered on the same day, meaning that, for example, 100 laboratory mice are injected with a dose of nicotine on a certain day, then time t equal to 0. For first method, at t equal to 0, all 100 mice are injected at the same time. So all 100 subjects at the same time. So then death happened all along the way. For example, the first 5 mice die. And then t equal to 2, another 10 mice die. T equal to 3, 20 mice die. And the observation will end, let's say, until t equal to so let's say t in hour. So if the observation period for 1 day, so t until t equal to 24, for example. And then the idea for this kind of method is to see the idea of survival viewed as time since the initial event. Okay, second method. All study units are gathered during a given period, with each unit has its own date for t equal to 0. Example, suppose a study is made of the survival pattern of persons diagnosed as having a certain terminal disease. For example, we are studying on coronavirus from day 1 until 14 days. For example, patient 1 come at t equal to 0, found that he has COVID-19, for example, at t equal to 0 for patient 1. And then at t equal to 1, day 1, 3 people come, and they went to diagnose stage and found that these 3 have coronavirus, for example. So 3 people at day 1. And then at day 12, another 2 people come, P5 and P6, for example. At day 14, another one patient come. So the difference is all the subjects enter the observation period at different time. So example 1, how to measure the observation times of death. Okay. Subject A was diagnosed on 1st March 2010 and died on 11 March 2011. Subject B was diagnosed on 1st July 2011 and died on 1st August 2011. How to measure in in days. Okay, we have two types of observation. We have calendar time and also we have follow-up time. Let's do the first one. 1st March 2010, he was diagnosed and died on 11 March 2011. So more than 1 year. If more than 1 year, what you're supposed to do, it's easier for you if you calculate until by a year. So 1st March 2010 until 1st March 2011, it become 1 year. So this one, 1 year. Since the measurement one in terms of days, so it becomes 365 days. And then he died on 11 March 2011. So how many days here? 10 days. So 10 days. So subject A observation times of death is 365 days plus 10 days. It becomes 375 days. Okay, how about B, subject B? Subject B diagnosed on 1st July 2011. So somewhere here, 1st July 2011 and died until 1st August 2011. So this is B. So it diagnosed at 1st July and then died at 1st August. So it is here. How many days? For July, 31 days. So at 1st August, he already died. Like this one, at 11, he already died. So only 10 days. This one, at 1st August, it already died. So he lived only in July, 31 days. So B equal to 31 days. Live how many days? Until 375 days. So the longest one is subject A. However, B live only 31 days. Somewhere here. So B only live from 0 to 31 days. This is how you draw for follow-up time or time under observation. Okay, now we go to the exact time of death. Okay, suppose there is a cohort of 5 subjects. So cohort is a group of people. So a group of 5 subjects is observed, each with death occurring at ordered time. T1, T2, T3 until T5. Based on the sample data, let's estimate the survival distribution applicable to these entities. So if we draw the timeline, so meaning that T equal to 0, T equal to 1, 2, 3, 4 until 5. So the observation period until T equal to 5. So For example, at t equal to 1, first person die. T1 denoted as the first subject. T2, second subject. Okay, so T2 die at t equal to 2. At t equal to 3, the third subject die, and so on. So we call it as ordered time because it happened one by one, from one time to one time. So the empirical distributions, we estimate ST using the observed proportion of the sample surviving each time point t. Much easier to observe by using graph. 1, 2, 3, 4, 5. And then the first death happened at 1, 2, 3, and 5. And then before 1, there is no death happened. Before 1, no death happened. So the survival time is 1 because all still survive. And then between T1 and T2, one person already died. So first we have 5 people. So here after one person dies, so we have 4 here. So here it becomes 4 people only survive over 5 because this is proportion. We are using proportion. So 4 over 5, and then S2 only, okay, second die, so only 3 left, 2 left, and then 1 left, and then here is 0. So the proportion meaning that you are calculating on how many still survive at the particular time from the total survivors at t equal to 0. As you know, survival function is decreasing, so ST also must be decreasing because it is estimated for the survival function. Large sample size will give smoother graph from rather than small sample. Can produce a smooth curve using the gradation technique. So these two just additional information. And then, okay, this is the most important thing to draw the graph. So how to determine the interval for the y-axis by using r over n, or in our case we just use 1 over n. For example, we have 5 subjects, so 1 over 5 is equal to 0.2. So our y-axis, we start from 0 and then 0.2, 0.4. So the interval must be 0.2. The y-axis start from 0.2 until 1. So what is y-axis? Y-axis is the observed proportion surviving 2 times t, and the x-axis is t. So how to draw this step graph? First, at t equal to 0, st is 1, so we start from here. And then the death happened at t equal to 1. The first death happened, so t1 here. So you draw here, and then at t1, 1 death happened, so 0.8 t2. So from t1 to t2, t2, t3, t4, t5, Okay, so it reduced one people and becomes 0.8. So go down. So each interval 1% die, and then at T5 all die. So ST become 0. So this is how you draw the step graph for the survival function. We end this session here. Thank you.